Welcome to Short Tutorials. For today we're going to learn multiple methods for avoiding machining features. So what we have in front of us is a part that has multiple features at multiple depths, and this is a problem that one user has faced. He wanted to rough machine the outside here, but he didn't want to touch this cavity. And so this is something common that happens. We would like to know simple methods in order to avoid that. Now, today we're going to learn 4 different methods. Let's start off with method number 1. I'm going to go into the manufacturer workspace, and let's just create a new setup. I am going to change the stock to relative size cylinder, change the radial stock offsets to 0 in this instant. And let's go OK. So there we go. Now let's first of all talk about the problem. Let's go to adaptive clearing. This is oftentimes what we see. I'm just going to select a 1/2 inch end mill, something I created earlier, so you guys don't have to see me do that. Now I'm just going to change the height, the bottom height to this surface. We don't want to go below that. And we want to do a multiple roughing step down, maximum step down of 1 inch. The height difference between the top of our model and that surface is 2 inches. So this is going to create 2 step downs. But let's see what happens here. All right, so here's our tool path, and it's exactly what is not wanted. We're going into the cavity here. It's milling all the way down that cylinder center. So we don't like that. Let's delete it. Let's get out of it. Okay, so here's method 1. We default to in our heads going right to 3D. Well, we've got an awesome milling machine. We look at our part and we think, well, this has lots of features in 3 directions, 3 dimensions. We've got flats on Z's, we've got different depths, we've got all this different. So our mind instantly goes to using adaptive clearing in 3D. But our first method is actually going to 2D. Let me prove to you how amazing this is. Let's go to 2D adaptive clearing. Great, so let's select our tool. 1/2 inch end mill. Now under geometry, look what we have here for our pocket selections. We can actually drop down and we see there's several different things that we can choose. We can choose a chain, face contours, pockets, pocket recognition, and so on. Let's just go to pockets. Now this is the wrong toolpath, everyone, but I just want to show you what happens. We can select our pockets here, 1 and 2. Let's go OK. Our height, let's do a selection of this face. Paths, again, we're going to do multiple step downs of 1 inch. And let's just do that. Let's see what happens. Hey, would you look at this? This is looking great. Oh, uh-oh. Look at our tool. Our end mill doesn't want to cut in the areas of our holes here. So it leaves these massive pillars, which obviously would not be good for our milling strategy. So let's go back. Again, that was the wrong choice, but just showing you that you can select, say you don't have holes there, that's one thing you can do. So let's delete our pocket selection, and now let's go to chain. So another dialog box comes up, and we've got 2 different modes here. We don't want to close chain. Now here we can see the definition changes the contour selection to open or closed. Open chain lets you select individual contours, and close lets you select a contour and automatically finds nearby contours to provide a closed contour selection. So in this instance, we are following this path. All right, let's do that. Let's pick open chain. Now let's select, we can actually select, well, let's select this one right here. We're going to select that as our first part of our chain, and that is our last part. It brings up 9 edges. It automatically finds the shortest route between the 2 of them. Let's go OK. Let's add another one. Let's go to the other side. Do the exact same thing. There we go. Okay, so now look at our face selection right here selects over the holes as well, which is great. And it actually carries out all the way to the edge of our part, which is amazing. That's exactly what we want. Then we don't have to fuss about this particular contour, although we might want to select that, but let's just leave it for now. Let's go to our heights. We're going to select, yeah, we still got that face selected, excellent. And our maximum roughing step down. Well, there you go, look at that. So now we've got exactly what we want. It will rough out the entire part, but it will ignore that cavity on the inside. So that's perfect. That is method 1. So let me delete that. So let's move on to method number 2, and it's actually using the adaptive clearing for 3D toolpath. So let's select our tool. We're going to select the same 1/2 inch flat end mill. Now for our geometry. If you ever see this rest machining, we deleted our previous toolpath already. So it's assuming that we have a toolpath there, and Fusion will automatically pick rest machining. So we can just uncheck that. Now for our stock selections, look at what we have here too. We have a bunch of drop-down items. Usually we would pick pockets or pocket recognition, but let's pick face contours here. Great, so we can select this face and same plane faces on the other side, but look at it, it's not selecting our holes, or it's not selecting the entire face over the holes. So how can we remedy that? Well, as our loops, we're not picking all loops, we're just picking our outer loops. And then instantaneously we've got a blue plane here, which is our cut plane, and it shows everything that is going to be cut. And then we can pick start outside. Let's do that. Our passes. So this a couple different things that we need to change here. We are going to not machine cavities, and we're going to turn, well, I'll just show you what happens with flat area detection. I'm going to do a maximum rough step down of 1 inch. And let me show you what the flat area detection does. Let's just go okay there. So even though we've disabled our cavities from being machined, look at what Fusion does, is it puts this lovely cut right into our cavity here. Is exactly what we don't want. And you can see some of the benefits and some of the not so good qualities of this toolpath is it doesn't do a nice job finishing the sides. Of course, we're not finishing right now. We're just doing a rough toolpath. But anyways, let's just go back to paths. Let's turn off flat area detection and let's go okay. Now what do we have? We've got a beautiful toolpath. Look at this. It's ignoring all of those different, the cavities. It's ignoring the holes as well. But as you can see, it's leaving not the nicest finished surfaces here. Now we can change that as well. We can go to passes. We can go to, let's take off some stock to leave. Let's go to 10 thou. Yeah, so one of the reasons why it doesn't clean up those faces very nice is we've got the optimal load to 0.2. So it's going to leave some pretty big scallops on those faces. Now that's not too bad. We can always do a finishing pass that has a spring pass and cleans that all up. But at least that's one method that we can do using the 3D adaptive toolpath. I'm just going to delete that now. Okay, so now we're going to move on to method number 3, which is in our 3D drop-down menu, and we're actually going to pick flat. This is a great toolpath that is highly underestimated, or underrated, I should say. So here we go, geometry. Now we can pick our geometry. Let's just leave that. Heights. Select our face there. Passes. Here we go. Type pocket is fine. Optimize open pockets. We can do a finishing path if we want. But look at this here. Machine over holes. That's what we want. Okay, let's just see what that looks like first. Okay, so right now we've got an issue. It wants to cut the top, it wants to cut the cavity, but this face looks fantastic on the bottom. So let's go into that and remedy it. So we don't want to touch the top face in this instance. You might decide that you want to finish that top face, but in our case we don't want it. So our top height is going to be the stock top. Let's just drop it down 5 thou. There we go. Now, if we go back to geometry, we can go to avoid touch surfaces. So you can pick avoid or touch, but let's pick our surfaces to avoid. We can just select that one and let's go OK. Now while it's generating our toolpath, you can see that it's doing an amazing job at finding those flats. It leaves quite a bit of material on the walls, but let's drop it down in our passes to multiple depths. We'll do 1 inch, sorry, number of step downs. Let's go 2. Maximum step down, there we go. Let's change that to 1 inch, okay. All right, so now you can see that it's almost perfect. We've just got an issue where at the very end of our toolpath, it wants to mill out a little bit of our holes for some reason. So let's just go back to geometry. Other faces that we can avoid. Let's just pick all 4 of those faces. Ooh, let's do that. 1, 2, 3, and 4. Okay, now let's see finally what it looks like. Let's let that generate. Hey, alas, we've got a nice toolpath. Let's simulate it for posterity. Okay, so here we go. As you can see, it's digging into our part a little bit. We can change that with entry and exit positions. But we get the point. This is just another method that we can use. I've got comparison on for colorization right now, so it shows what stock is left over. We've got plenty of stock to finish up, but this toolpath does a fantastic job at machining our walls and not machining the cavity. So let's stop there, and I'm going to delete this toolpath. Now for method number 4, it's probably my favorite method in many instances, and it's a method that a lot of Fusion users do not utilize to the full. So let's do it. Now our model right now is the model that we have created, but there is something very special in Fusion called a manufacturing model. So just read over this. What is a manufacturing model? Well, it creates a model for use in the manufacturing workspace so that you can edit without affecting the original model in the design workspace. After creating a manufacturing model in the browser, double-click the manufacturing model to access a contextual environment where you can use common design tools. A common use case is to create a manufacturing model for an additive workflow that resembles the final workpiece or the final part, referred to as the near net shape. You can use this part as the stock for another setup and then use a subtractive workflow to machine any part features like holes to complete the part. So this is amazing. Let's look at an example of this. Let's create a manufacturing model. It automatically brings one up here. So there we go. We're going to double click it. And then look at what we have here. We've got, it's like we're in the design workspace. We can change all these different features, which is really handy. So we can adjust anything here and it won't affect the main model that we've created. And in fact, once we change this, if we change something in the main model, Fusion is very smart. For example, if we put a post that's sticking out the side here on our main model, we come back to our manufacturing model and it will have that post sticking out, but it will retain all of the adjustments. So let's look at an example of this. I am going to, let's delete all of this here. Come in there. Oh, delete that face too. Okay, let's delete all of our holes. Just to start. There we go. Let's delete them. Okay, and then I'm going to delete all these rads as well. So this takes a long time, but that's okay. In some instances, this is the way to do it. This is the way to go. It will save you a lot of heartache. So let's just delete those. Fusion is very smart. Now you might design your model as well. If you don't need to have these rads, if you're just going to use a ball nose cutter and finish this part, well then so be it. Don't put the rads in. Rads sometimes, or fillets, take a lot of processing power, extra processing power. They're there for renders, but sometimes they create issues. So here is the main thing that we want to fix. Well, let's just finish our rads on the top. We'll do this all together. Let's just select everything here. Pick that. Excellent. So we're going to select everything that's connected. There we go. A couple more surfaces and press delete. And look at what we have now. We've got our part with no cavity. We've got no features. We've just got the surfaces that we would like to machine. This is very handy. We can go finish edit. And now we've got a manufacturing model. So let's go to setup 4. And look at it, defaults right back to our main model. But now we can pick under our setup, our manufacturing model. Instead of picking our default, let's pick our manufacturing model 1. Yes, we want to change it. Look at this. It automatically changes to the manufacturing model that we've just created. It's got no cavity. We don't have to worry about it now. And now we can pick so many different, let's go to our stock. Let's change it to relative size, cylinder, 0 offset, stock offset. There we go. And now we can pick these other methods very, very easily. Let's go to our 2D adaptive clearing path. And here basically we don't have to worry about anything. We can just pick those two. Our heights, yeah, let's do that. Passes, multiple depth at 1 inch. Let's just see what this looks like. And look at this, all of a sudden we've got a beautiful path that takes care of our entire model in a very nice way. So I wholeheartedly recommend that you get used to using manufacturing models. So now look at this. Once we finish this, if we want to create a new tool path that can cut out our cavity, what do we do next? Well, create a new setup. And what we're going to do is use our default. Stock is going to be from preceding setup. Continue rest machining. Yes, we want to do that. So now look at our stock right here is exactly as we have finished from the previous setup, but now we've got setup number 5. Perfect. So it brings up a little alarm, continue rest machining, cannot verify that the stock is transferred. So that's okay. Let's just go into it. Now we can go adaptive clearing. We can pick a smaller, end mill. Let's just go to a flat end mill. Let's go to a 1/4 inch. We're going to put that in there. Perfect. Let's pick our 1/4 inch end mill. Adaptive geometry. Let's just pick our selection here. There we go, passes. Now it should mill out this cavity, no problem. Of course, there's probably going to be a collision because our end mill is not long enough. But look at this. Now all of a sudden we can cut out that cavity using another tool without any problem. So it's an amazing technology that Fusion 360 has to use manufacturing models. You've just learned 4 different methods to ignore cavities or ignore features that you do not want to machine. I wholeheartedly recommend that you review this video, you look at each tool path or each method so that you can utilize the best method for yourself and your parts in the future. Anyways, I hope that you've enjoyed this. Please, I would really appreciate you liking and subscribing. Turn on that notification bell. It helps us immensely. If you have any comments, any suggestions, please write them below. Please feel free to message me. I will try my best to respond. And if you have any suggestions for upcoming videos, I would love to hear them too. Please write them in the comments section. Until next time, thank you for joining the Learn It channel. Hope you take care and enjoy your cam adventures.